Anyway, I had
Yeah,
a
yeah. I'd like to co-op to build, a basic command line wallet. I tried to get uh, Kayvon involved in that, and now maybe Ovidu. Anyway, go on.
yeah, until somebody gets the energy to actually start it. Did they schedule some of it in no, because I don't know if there's actually any tickets to do anything.
I didn't happen to see any.
Yeah.
Ovidu may have one related to testing or something, but so Kelly did schedule a wallet meeting for next week sometime, or the week after, forget which, after the first, for certainly.
I just want to peek at this. Doc test is a comment-driven development is a bad idea. I disagree. Doc tests are wonderful. Anyway. Anyway, it's a little bit of a controversial idea. Not worried about it too much. But I can't close that window because, Zoom makes certain parts of the window unusable. There, okay. Okay, so voting. Whoa. So there's, let's see. What's his name? I can't remember his name. David, I think, was talking about, he was asking me a question about the voting thing. He mentioned that he was going to try to work on the bounties. And I said, which ones? And he said one of them was the converting this voting contract from Solidity. And I said, oh, that might be a little subtle. And that sort of got my brain thinking enough to sort of scribble on it myself. I don't know if he's made any progress. But what you notice is that in Ethereum, you can always ask for the message sender, right?
Oh.
And that's not a thing in rholang.
Yeah, and that actually may be another contract in Ethereum.
Right. But it's very much like the refer thing in the web, which turns out to be a security nightmare. Well, not necessarily a nightmare, but it's a big decision to make. We didn't really think about it very hard. So having to give away your identity every time you make a call does not let you do a lot of OCAP patterns. Besides, you don't have an identity in general.
Right. It could just be whoever signed the transaction. And in Ethereum, I think the way they do signed payloads is, I may be confusing this with Bitcoin. You can find out the address. You don't have to provide the address separately. But
well, yeah, I mean, in Ethereum, every call comes out of a transaction, which has a sender and a to and a from and an amount and all that kind of stuff.
Right.
Yeah. So in rholang, it's just a send. It's just like a function call. It's like in
Oh,
JavaScript. Well, I guess in
well,
JavaScript, can you get at the caller? I can't remember.
I'm sorry, I don't remember, but I thought that both in well, in elliptic curve in general, there's a way to sign the payload such that you can look back and actually find the sender, or not. That's kind of an option in the way I thought that.
Right, but rholang in general, there's no signature anywhere near. You don't have access to any. It's just a programming language like C. You don't. I guess you can sort of look up the stack and see.
But everything that hits Casper has a rev transaction in there. So is
Say
needs to
that
be
again.
signed, right?
Say it again. Everything that hits Casper.
Every 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 I know transaction is a bad word, but I'll use it. Every transaction coming into Casper has a rev transaction, and so has assigned a signature around it.
Oh, right. Every deploy, I suppose, was paid for.
Deploy, yes, sorry. Yeah, thanks for translating. So every deploy has to be paid for, and if the signature over the transaction is such that by convention you could figure out the sender address, then that's sort of like message.sender.
Yeah, and that's actually they do have some conventions for going and asking things about the deploy. In fact, they may already have what you're talking about. That's an interesting question. Let's go look that one up for a sec. Yeah. Short leash params. Somebody has to define this thing.
Oh, what short leash is? Yep, it's not done.
Is it in the? Nope. Rolling interpreter short leash. Rolling interpreter runtime.
Yeah, I have a conception of what short leash means, but what I didn't think that was related to our question of message sender.
Oh, here we are. Code hash, flow rate, user ID. There you go. Timestamp.
Oh, okay, different than I expected.
So there, you can get at the person that deployed the contract.
Well, I thought user ID was a self-reported and not cryptographically checked value. That's kind of I thought that was an application, or either that or just wasn't finished, a couple months ago, when my
Yeah, who knows? Yeah, they're not checking any signatures with it now, but I don't know whether it would, it's different. It doesn't seem to be the same as from. But anyway, code hash, that's interesting.
But I thought short leash, the concept was when you had some other mechanism pay for the gas price. So, for example, on the um, wallet check contract and how that works would have some short leash kind of concept that the user wouldn't have to pay for it. Or am I off base of what short leash means in our?
I'm not sure. As far as I know, every deploy has short leash stuff. I mean,
Okay, I didn't understand what it was then. Okay, or understood differently.
I think short leash deploy, it means you can only deploy a payment, and you use that payment for your next deploy. That's my best guess right now. I'm not really sure.
But going back to my earlier comment, isn't with elliptic curve signing, there's a convention or way to do that such that with just the signed message, you can find out who the signer was by public key or perhaps address.
Yeah.
So it may not be exposed, but if we use that convention, then it's probably there in the deploy somewhere.
Right. In any case, so right, they keep track. They use the addresses as identities all over the place.
Mm-hmm.
Only the chair can vote and all this kind of stuff.
Mm-hmm.
And then, so I started to build it in rholang. Oh, so here's the ballot. And this, I was able to run a little election down here. There's a ballot between Lincoln and Douglas, and this is the public key of the chair. And then what you get back is the sort of the chair unforgeable name, the sort of right to act as the chairperson, and the way to ask for the results, and the way to forward a ballot to delegate. That's what I started on. I didn't get very far. Anyway, so then the chairperson can give the right to vote to one person and to another person, and then those two people can vote. And then they can try to vote again, but they lose. And then after they voted, you can ask for who's the winning proposal. And that works. This version doesn't work because I wonder what happens if I run this version. Oh, it does. Okay. Lincoln got 2 votes, so he won.
Yay.
Yeah, already voted. And I started, like I said, rebuilding a lot of that, because you can do the same thing where you you take the chairperson's public key, and then here I don't have to check the signature because this comes from an unforgeable name that I handed out. I'm trying to think of. Okay, well, anyway, the idea was I was going to sort of have this gateway thing where if you wanted to exercise any of your rights from off chain, you would just send the method and the args and stuff signed, and then this gateway thing would forward it to the relevant part of this thing. And then I ran into a kind of a weird thing where just wouldn't let the chairperson vote. But anyway.
So you were trying to faithfully repeat the Solidity contract here, and it had these concepts of a gateway.
The Solidity contract does not, but the Solidity contract has the message.sender thing that all Ethereum things have. Well, it's not really sender that I'm after up to, but it's the fact that the calls all have to come from somebody with the public key, right? So that's what and this chairperson thing, you can't just like, if you want to get at this, if you want to actually use it, right, as a person, then you have to be able to make these method calls. So you have to be able to call them from off chain, right? And so if you call this ballot thing, it'll give you a chairperson thing back, but then unless you put it in the registry or something, it's going to go poof, right?
Yeah, when you say off chain, you mean just adapt wherever the data comes from. Yeah, okay.
Right. So, right. So there has to be something that you can register on put in the registry, and the thing that you put in the registry then checks signatures before it forwards them to the guts. Does that make sense?
Yeah, I have a little bit of conceptual questions around registry, and that'd be interesting to explore later in the call.
Well, no, we should get solid on it now before we.
Okay, so let me first ask: are all registry, the mechanism of registry, is it all the same for every registry entry, or are there multiple different types of registry entries?
They're all the same as far as I know. There's two ways to put things in, but other than that, they're all the same.
Okay, so what are the two ways, if you don't mind?
One is insert arbitrary, and the other one's insert signed.
Okay, and sorry, would you mind taking a few minutes and walking through those?
No.
I'm just at the conceptual level. I'm not so worried about this syntax.
Right. So insert arbitrary is reasonably straightforward. You make that call, and it gives you back a URI, and then you can later use that URI to look up the thing.
Okay, and it creates the URI, and it's non-predictable.
Oh, it creates the URI, and it's as predictable as unforgeable names are.
Oh, okay. Okay, and then insert signed?
Insert signed, you give a public key, and you basically sign the insertion and you give the public key, and then you can come along later and update that registry entry.
And the URI that no, there's no URI. It's the public key that's the lookup.
No, I think insert signed also creates a URI. I'm a little less clear on that one.
Okay, so at the end of the day, there's a URI, and you can in the case of insert signed, you can update the value. Is that also true with insert arbitrary? You can update the value?
No, because otherwise it would be totally insecure. Anybody could, there'd be no way to prevent anybody from updating it.
Okay. So insert sign is updatable, insert arbitrary is not updatable.
Right.
Okay, that helps a lot. All right, let's see. Where were we? Oh, so I was going to make a comment about, this is a little maybe getting abstract, but when I think about voting and ballots, and this inspiration was either intentional or unintentional of some post that Mike Stay made maybe 3 months ago, when he was describing Casper and the validator decisions within Casper. And I was also thinking about multi-sig wallets at the time. they're kind of related, right? You have a group of parties that together need to make a decision. And there's some initial special role of the person creating the contract, in this case the chairperson, but in the case of a multi-sig wallet, after that, the way that Gnosis works, for example, everyone gets a vote, and that's kind of how Casper would work. So if there could be some core rholang that could be leveraged, that and tested and put pressure on, that this kind of multi-sig decision making would be leveraged in all three cases: Casper, voting, and multi-sig wallets. That would be really helpful, I think.
Yeah. So that's kind of one of the intuitions. It's like doing intuition around the locker. But yeah, just in case you're interested, the cross shard transfers thing is there, and there is a multi-sig thing in here somewhere.
Oh, that's where I saw it. Yeah. This is post Mercury, but right?
I believe so. Yeah, I did some testing on this, trying to understand how it works. I sort of understood it for one brief shining moment. But yeah, so if you roll back your thinking from multi-sig to just single sig, you'll notice that we have several contracts that have this business of, okay, I'll check your signature and then and then actually make the call, right?
Uh-huh.
So one of them is, where do we put it here? Right. So we have our the status app, which is kind of like the little teeny Twitter thing. I don't know if you ever saw that run.
Don't recall ever seen it.
This was what Joshi presented at DevCon in Bonin.
Oh, I did see it then. Okay, yeah.
Right. So it was a little web page where you can say, I'm skiing, or I'm...
Oh, yeah. I saw that, yeah.
Okay. So it has the same thing, right? Here's data signature, pub key, success, failure. It checks your signature, and if it's okay, then it's going to go ahead and...
Great.
Then it's going to go ahead and actually do your new status, right?
Yeah, this looks familiar now.
Okay. So I thought, and the other thing is, in the object capability community, so one of the capability patterns is these long random number URLs that you can get from Google Docs.
Mm-hmm.
And if you hand that to anybody, then they can read your document, right?
Mm-hmm. Yep.
So it's like, how do you keep track of those things? What if they were really important, where would you put them? Okay, well, you put them in a what do they call it? Key management app, like KeyPass and things like that.
Yeah.
So that's kind of what this is.
Locker, yeah.
There's a well, here's the test. Sometimes I think I should put this test at the bottom. At the top. Okay, so I'm going to allocate some names, and then I'm going to call locker, and then here's the public key. It's not a real public key. Here's the signature checking.
But it's hex.
Yeah. Where's the signature checking? Yeah. If dead plus your signature is your public key, then you win. So dead beef. Okay, so I call locker and I say, here's my public key, and please give me a locker back. Okay, I got a locker back. And now I make a new trinket and I print it, and then I call locker store and I sign it. you can store as many things at once as you want. So you give it a map, and it sort of unions the map. And there's a fail channel and a succeed channel, and the fail channel just goes to standard error, and if it succeeds, then we're going to go ACK. And notice that when we're down here, the trinket thing is now out of scope, right?
Yeah. Oh.
But we can get it back from the locker. So locker get, and then again, I have to sign this call, and there's a nonce that goes up. And again, if I lose or if I win, and if I win, I got the item. So watch this go. So there's the trinket. Win, I got the trinket 954, 954.
Great.
And then this locker I can register.
Okay, and that's with insert signed or either?
That would be interesting to do it with insert signed. But it's not. It's insert arbitrary.
Okay, okay.
Right. So you can have access to my locker.
Yeah.
But you don't know the combination, so you can't get at the contents.
Okay, interesting.
Anybody can see my locker. But in order to get stuff out of it, you have to...
you have to know beef or whatever.
Right.
Okay.
So the sort of, this code kind of works, and I'm sure I could do the real signature checking. I've done it enough times. The question that I don't know if anybody here is equipped to answer is, suppose that the signature was only over the nonce. Because in the basic wallet contract, the signature is also over the return channel, which is a royal pain in the tuchus. Clearly, Ethereum doesn't do that. Although they do sign the parameters like the amount and the destination and stuff like that.
Yeah. No.
So the idea is you would get the whole bucket of items, and then you could pick any of the items out and do whatever you want with them. So your items might be like your right to vote, or your right to act as the chairperson, or a purse, a raw purse, not a wallet.
Oh.
So this is like a generalized wallet.
I wouldn't thought of it that way until you just said it. Okay, because you can put stuff in it. All right.
Right. And then when you get the stuff out, you can do arbitrary things with those things. They're just capabilities, and you exercise them the way whatever it is they are exercisable.
Oh, that's an interesting leap that you made for me, which was the locker has, in essence, a collection, could have a collection of capabilities. One of those, in essence, is a purse.
Yeah.
I haven't thought about data, which are small programs in our world, as capabilities until you just said that. Am I tracking correctly, you think?
Yep. That's just, yeah.
Okay, but that's a little light bulb in my head that just cool.
Yeah, they're just, in other programming languages, they're just objects you can call methods on.
Yeah.
If you got a handle on the object, then you got the capability.
Got it.
So another way to think of it is it's a personal registry.
Yeah. Nice. Yeah, this would be. So, is your intention to make Locker a sample contract that would ship with the platform ideally, or just another sample, or a core piece of the platform?
I don't know. First, I want to see if the security thing is reasonable. Like I said, the signature for get would only be over the nonce. Well, or maybe it would be over these return channels. So I know the nonce is there so that to prevent replay attacks, because if you, for example, if the signature was over the same thing every time, then somebody could just take an old signature and call that, and they could get access to all your goodies.
Exactly.
But if it's over the nonce, then you have to sign something different every time. But I don't know if the nonce is like enough entropy or whatever that makes it. Maybe you have to hash the nonce, and who knows if that even helps.
Yeah, it's the quote unquote sender, meaning the party that's the public address that's paying for the rev, plus a nonce, plus some other message payload. That'd be cool. That'd be enough.
Yeah, I just don't know what makes a signature secure. Let's see.
Well, it's secure from replay, right?
Right.
Hey, I'll be. I need to go on mute for a couple minutes. I'll be right back.
All right.
Check in on my wife. I'm back.
Curious about best practices with signatures.
Don't use water-soluble ink.
Cryptographic best practices. Hey. Fundamentals of a just
Oh, you're sharing your orders, by the way, Dan. What have you been up to, Jim?
Mostly playing. I mean, this is relevant to the object capability stuff that I've been playing with, which
Nice.
haven't really figured out how to do. What I well, I don't know if you've looked at it at all, what I've been playing with, but I created a lightweight object wrapper where an object is consists of a class and an instance, and then I basically have a pattern of methods that you're allowed to call, which consists of the object, the method, and a list of arguments. And I guess the main purpose behind this was with the other object patterns, you had a copy of the contract with every instance of the object. And this separates the contract from the object definition.
Got it. So it's creating a permission to a specific invocation.
What do you mean by a copy of the contract?
Well, if I use the instance as part of the name of a contract in the node here, if this was part of the name, then there would be an instance of the contract for every instance of a node. Whereas here I only have one instance of each contract for the node, and the instance itself is just this one tiny contract, rather than having a separate contract for each method for each instance.
I don't think the code gets copied in any case. I mean, you allocate names every time you do a new, but I don't think you're saving yourself any names. Anyway, that's something to think about. Yeah, I mean, we don't have any mechanisms for copying contracts, I don't think.
Well, Jim, is your intention to create like a permission facade on one particular use of another contract?
Yeah, well, that was part of it, and maybe we didn't need to do that. I guess in one of the sessions with Joshi.
Maybe I'm confused. I don't know. I have to think about it.
You know, every time we created an instance, we were creating another copy of all the contracts. Now, maybe that's not true, but
yeah, something to think about.
because I mean, you invoke the contract. And you're basically creating channels for each method that are unique.
You're creating what now? The only time we create anything is with new. We just create names. I'm pretty sure. Yeah, I have to think about that.
Hmm.
So yeah, thanks for sharing that, Jim. So on the back to the voting thing, Dan, what are your what are your intuitions of where that will go next, or should go next?
Yeah. So.
And do you see some merit in my intuition to, again, for me, a lot of this is to have things click at the conceptual level, then that opens new ideas. But in terms of actual implementation, do you see any value in combining the implementation for a multi-sig kind of authentication, whether it be in voting, Casper, or multi-sig wallets?
Yeah, it would certainly make sense to have a multi-sig locker.
Oh, got it. And then that would be just a low-level registry, not a low-level registry, but it would be I don't know what you call it, an idiom for handling multi-sig that would be well understood.
Right.
It would be in the locker, so arguably it'd be a little more public than some people might want. But it's, public is a relative term. It's on the blockchain, but it is secured through the locker, through the registry mechanism.
Right.
Yeah, that's an interesting concept, a multi-sig locker, and that could be to any general capability, whether that capability is a final vote or an approval for another transaction.
Right.
Yeah.
So the question is sort of whether this is a reasonably secure pattern. So the patterns we've seen so far have all been where the signature is about one way of exercising one capability. Right. So the wallet contract, the basic wallet contract, you pick a signature, and if the signature checks, then it's going to transfer a certain amount of money to a certain place.
Mm-hmm.
And this is saying if the signature checks, I set everybody free. And there's I could make a one that says, get just one item out of the this map, the items map thing here. It just seemed, or I could give me a list of them or something. Maybe that would be the way to do it. You get a list of names, and then back would come a list of objects. That way you'd have to at least sign their names.
Mm-hmm. It'd be interesting to have one of the core developers, unless you're already familiar with it, walk through the, bonding, Casper bonding, and Casper slashing decision making, I guess you could call it. Because I think of those as multi-sig kind of actions, where you have to have a quorum of yays to affect the action. But yeah, I'm not familiar with what's in place now. Yeah, I guess they're weighted votes. Some votes are more important than others based on the bond amount, or yeah.
So tell me what makes you think this is multi-sig or something?
Well, it's so in like the Gnosis multi-sig wallet contracts on Ethereum. It has the concept of a consensus or a threshold that, when there's, 2 of 3 signers,
Right,
goes through. And I think bonding and slashing have some of the same thresholds for enough validators reaching consensus on it.
I guess that's what I didn't. I don't think so. I don't think you have to get lots of people to agree in order to bond. You just have to put up enough money. That's the way I read this contract.
Oh, okay. Okay, so maybe bonding is a bad example, but I thought for slashing and just the voting that occurs on a block would be based on the weighted stake, and that's how it measures a quorum or a consensus on the stake. So
yeah, the Genesis, there is voting, and I don't think we use rholang for that.
Mm-hmm.
I haven't looked at that one real carefully.
Okay. Anyway, these are just kind of abstract intuitions I'm having.
Sure. Well,
they're valid.
It's part of the game here. The other sort of part of the random walk, no, not that one, is this stuff. Jim, have you taken a look at this?
Yeah.
I looked at it. I didn't get too far in terms of following it, other than the general concepts. I didn't get it. Maybe you can shed some light on it for me.
Okay. The first part's, I'll go into those in some detail. This part I don't completely understand yet. Behavior is the only thing we can actually observe. Identity and agencies are always inferred. This consensus is reflected in conventional wisdom. Watch what people do, not what they say. So that works for me. So then blah, blah, blah. Then we get into sort of the really interesting stuff. If these can be made consistent and coherent by interpretation of a wide range of organismal and organizational behavior as channel-based communication acts, then so much the better. So we're scaling up from maybe individual identity to organizations. And then he goes all the way down here to says a behavioral psychology that relates these two as via scale invariant theory of behavior is invaluable asset. Oh, wait a minute. At some point he talks about modeling psychology of large populations this way. Oh yeah, a behavioral psychology that relates these two would be invaluable. Yeah, so that's a really interesting thing to me because there's this thing that Tim Berners-Lee was sort of anticipated this business where YouTube mostly gives out misinformation, or YouTube is really amplifying the flat Earth signal, right? Mm-hmm. So he was worried about that quite a while ago, about the idea that, okay, the web lets information spread really quickly. What if it lets misinformation spread really quickly? Mm-hmm, mm-hmm. And so there's this web science stuff where they were trying to sort of study that, but I never saw any real progress. But if you could make a system where you could somehow predict whether it's going to cause people to behave well or behave poorly, wouldn't that be something? You know, at a large scale.
Yeah.
So that's what I think is what he's talking about in behavioral psychology.
Yeah, reputation can, you know, quote unquote positive reputation can be built on misinformation and just people's poor judgment that believe it. So, you know, irreputable people build reputation, so to speak.
Right.
And that could be with whole populations.
Yeah. I mean, it would be interesting. So like TCP, for example, is a specification of packets that go back and forth between two nodes.
Uh-huh.
But the net effect of it is that you can share an Ethernet connection and it won't get bogged down.
Mm-hmm.
Right? And there's nothing in the spec that says don't bog down the Ethernet connection, right? It just says if your packet gets garbled, back up. Well, that's the Ethernet spec, not the TCP/IP. Anyway, but there's these large scale effects we get out of these small scale rules, right?
Yeah. Yeah.
Okay. So if the mechanisms in this paper have, you know, can do large scale modeling out of small scale rules, it would be really interesting.
But don't you miss the large yellow screaming Ethernet cable that was, you know, at the back in the 70s and 80s? It was coaxial.
Okay. So then I guess he's got in mind sending this an audience that doesn't already know rholang. So here's rholang, or row calculus to start with anyway. And again, the whole specification of row calculus. And then some syntactic sugar, which is basically rholang. And then the ability to do contracts and call them. Now, I don't know why he doesn't use actual rholang syntax there, but oh well, that's what I went and did. Okay, so I'm going to skip forward and go to what I think is motivates a bunch of this stuff. There we go. Okay. Now we're in a position to state what an identity is. An identity is a theory of capability that picks out an agent up to some equivalence. So I don't know if you've ever been in these philosophy discussions where one person says Bob and they refer to a person, and then the other person says Bob and they refer to Bob's shirt. You can have a whole conversation where both interpretations are consistent, right? Oh, Bob's over there. Bob went upstairs. Right? And so for a lot of things, it doesn't matter. You know, you might, you know, if you want to arrest Bob and, you know, you want the police to convene on where Bob is, then it's okay if you're just, you know, if one guy just thinks it's Bob's shirt because the police are in the right place.
And it's fun that, yeah, in a sense, this whole paper was building to the last paragraph here. You know?
Sure. Well,
cool.
He's good. He's, you know, that's how papers are written. You state your claim at the top and then you get to it at the bottom. But, okay, so a theory of capability is basically saying anybody who can, so for example, one of the theories of capability that's very, very widely used is anybody who can read this email address must be the guy that I'm dealing with.
Mm-hmm.
Right? So that allows you, so first of all, it's anybody who has this password is the guy that I'm dealing with, but maybe he forgot his password. So anybody who can read this email box, I'll let him replace the password.
Right. And that's very broadly used. Lots of banks trust that.
Right.
Just scary.
Well, they only trust it so far. There's all sorts of backup mechanisms.
Yeah, FDIC.
Right, but that's a theory, right? Is anybody who can read this thing. So up here, he starts to use rholang to talk about such things. All right. So Morty expects Rick to be able to send back to Morty an email containing whatever Morty sent via text. So maybe this isn't Morty's whole idea of Rick, but one of the things Morty thinks about Rick is that he can read email and send it back via text, or read text and send it back via email. Does that make sense?
Yeah.
If you're a person and I send you a text, I expect you to be able to, read the text, type it into your email, and echo it back. And so this is some pseudo rholang there. And this is actual rholang over here. So the differences are I have to new my Rick and Morty that I used at message. You could either use at message here or star message there, but you can't use just message in both places. Because you receive names and you match processes.
Okay.
And then I've got to trace every time. There's a pattern in my rholang writing, which is that inside every 4 I trace. Like, did it get this far? Did it get this far? Did it get this far?
Oh, that's good to know. Yeah.
I start by writing it without the traces because I'm optimistic, and then when I go, hey, why didn't that work? And then I start.
Yeah. I've been doing something similar on the wallet app. Just print line. Did I get here?
Oh, and the other thing is if you just say case V, that actually introduces a new binding for V. So if you want it to actually test whether it's equal to the existing binding, you have to write it this way.
Oh, okay.
That one, Mike Stay actually answered that one for me.
Yeah, that's not obvious. Okay.
Right. Okay, and then here's a demo or a test. So here's Morty's email box and Rick's text thing. And Morty. Oh, we're going to do the Morty behavior using Morty's email, Rick's text, a simple message of hope. And then here's the lose behavior and here's the win behavior. This is kind of interesting because these processes get sent but not executed at this point.
Okay.
Yeah, there's no special marking that they're quoted, but they're sort of held in suspended animation. Isn't that kind of cool?
It is. And then let's say, that it's eventually one. When does it go out of scope, or when is the lose part garbage collected?
Oh, I don't know when anything gets garbage collected. I mean, it goes out of scope down here, right? There's the scope. Oh wait, no, here's the scope.
Yeah, does it okay, so it's
but scope and garbage collection are different.
Yeah.
You can garbage collect something when nobody has a reference to it anymore.
Right. If it goes out of scope, it's deleted.
No, because I might have sent it to somebody in here and he might still have a reference to it.
Yeah, but it's sent on the outgoing channel of the win or lose channel.
Okay, anyway.
Okay.
So then then I actually instantiate a contract that exhibits the behavior that Morty expects. If Rick gets something from text, then he's going to mail it back. And then you run it. Rick text got a simple message of hope. Morty email got a such simple message of hope. Echo succeeded.
Cool. Yeah, so that's a good supporting example for this paper.
Right, reasonably simple one. Jim, what you think?
Yeah, I guess capability and channel based is, I guess, a good point. I guess I'm trying to figure out how that extends. I mean,
Right, yeah.
It's very important. I think the whole locker that you're building, or the object directories that I've been working on, are using the idea of channel security as opposed to using the registry or something.
Right. I just meant, does this echo example make sense?
Absolutely. Yeah.
Okay. And then I'm confused by the next section, because then he says Rick ought to be able to take a message. Oh, there's the simple message of hope. The next one is called paraphrase, and he says Rick ought to be able to receive something, do a summary computation, and send it back. But as far as I can tell, this rholang is completely analogous to the rholang above, except that he's changed the MSG to T or something like that. So there is no summary computation in this rholang. He doesn't take the length of the thing or whatever. So I'm a little confused by that section. So skipping ahead. Then he gets into the claim stuff, which is where he starts to talk about, well, it's going to overlap with the whole verifiable claims thing, I think.
I was hoping he would use more directly the W3C terminology here, but exactly, it overlaps.
In what way is he not using the W3C terminology?
He may have improved it since the last time I read it carefully. So claim is used. I'm not sure the notion of attestation or revocation of a claim are also other important parts of the verifiable claims protocols.
Okay, so he might not have covered the whole space, but is he actually using the same word in a different meaning, with a different meaning?
No, I think it's consistent now.
Okay.
I think, yeah.
Yeah, I haven't seen him get to revocation yet.
Or even attestation. I guess, the echo is a kind of attestation, self.
I don't think he's talking about this stuff up here as claims at all.
Okay, but isn't it though? It's when you
No, he's got this distinguished thing called C.
Okay, but I meant when Rick asked Morty, can you echo back this on a different channel or on the same channel? Isn't that kind of an attestation to say, yes, I'm Morty?
Oh, in a certain sense, yeah. It's exhibiting an expected behavior, which is part of authenticating yourself, yeah.
Okay. But yeah, okay.
In other words, if you can't do that much, you must not be Rick.
Got it. Okay.
He hasn't gone the other way. He hasn't gone and said, if you can do that, you must be Rick. Well, although in some sense, we're only sending to Rick's text, and maybe only Rick can read Rick's text. So maybe it is saying that's necessary and sufficient to be Rick.
Well, no, I mean, he's, I think, said in this paper and certainly elsewhere where I'll use the word trust, although he doesn't use that, I don't think, in this paper, but the trust or veracity of identity is, you know, consistent behavior over a number of different channels, which I think is a really great intuition and model to think about.
Oh, he does say that
Okay.
here.
Okay, sorry. It's been a little bit of time since I've read it. Great. I think that's a really great insight and a well summarized position.
Where did it go?
That should be like its own call out, right? Because it's just such an important concept.
So here he talks about if the information is sufficiently challenging to guess, then that establishes where does he talk about channels?
I'm just suggesting that if he can
yeah, communication acts across a range of channels. Somewhere he actually makes that point.
Yeah, I know he has verbally before. So I'm just saying it would strengthen this paper if he used the terminology at least in a few spots more prominently. We could win some brownie points with that audience.
Right. I'm just trying to figure out in what way is he not.
Okay. Yeah. Maybe I'm just looking for a more complete use of attestation and revocation. Revocation is in all the self-sovereign identity topic. Really, it's the revocation or the publication of a revocation that makes blockchain interesting.
Okay. So yeah, all right, that's fair.
Yeah. And then he doesn't use the word trust, and I don't know if he uses the word reputation in here, but I think those are important concepts, keywords to people to wrap their mind around this. But yeah, this is a really interesting paper and thought. It's consistent thought.
Yeah, here's where he talks about many channels. If we increase the number of channels, then it's more likely to be rigged.
I assume both of you have seen the Rick and Morty animated.
I've only seen the commercials for it or something. I don't think I've actually.
Oh, you got to just watch one episode, just any random episode, because the setup for it is so interesting to hear, because there's these parallel universes of various Ricks and Mortys, and you don't know which Rick you're talking to and which Morty you're talking to, because there's multiple of them. So that the premise is really great for this paper.
Right. Okay.
It's funny.
Okay, so there's that example that I think he's got a typo in or something. Okay, and then we get to this claims thing, where you read is claim by an agent that the property has value, and if so, do the success behavior. And it's shorthand for this. And that one's pretty straightforward to write out. CA, and then I went and said that P I'm mostly going to use as a process, so I'm going to do that. I'm going to pattern match it that way. Likewise, V. S I'll leave it as a name. And then I had a hard time getting this match to work, so I wrote it slightly differently. I deconstructed X at this point into PP and VV. And then if the PP matches P and the VV matches V, then you do the success behavior. Otherwise, you loop, which is kind of interesting.
Why loop?
Yeah, I asked him that, and he said that it's kind of like claims. This models the fact that claims are only semi-decidable. That is, in general, there may be a way to establish that the claim is true, but just because that you can't prove that it's true doesn't mean that it's false. It just means you don't know.
So meaning as more claims come in on more channels, is that why you loop? No,
it's just saying that okay, this thing is sort of one-sided. It's only useful if you have evidence that the claim was made. If you don't have evidence that the claim was made and you call this contract, you're going to get an endless loop. You're just not going to do anything interesting. It's going to diverge, I guess. It's going to be very expensive if you actually did that on chain.
But there's not a way to do the equivalent with a for comprehension of waiting for some condition to occur, or?
Well, that's what this does, essentially.
Okay.
Oh, I see what you're saying. You could.
Right, two expressions within the for comprehension. I don't know.
You could only fire if you get the right thing, and sort of not fire otherwise. On why you loop, I'm less clear, but he explained it sort of to my satisfaction. It sort of appeals to me that these things are only semi-decidable.
Okay.
In general, and then he's saying that if you can.
No, that makes sense. Like if you were spending gas on it, you might want to say, I only want to spend so much rev on this, and if I run out, I'll make some other decision, or just
right. Yeah.
Assume they're not reputable.
Right. Okay, and then he's saying maybe there are cases that are decidable. In which case you'd have a thing that splits the world into good things and bad things. And then he goes, I didn't play with that very much. But I did.
Yeah, this is fun. I'm going to need to bail here in a little bit just because of scheduled time.
Oh, yeah. Wow. Time does fly.
Now, this is fun, Dan.
So he's got a couple examples down here. I mean, I did a sort of claim of, Rick's favorite color is blue or something, and it all worked. But then he says he got some examples. Summer can email Beth that she saw Rick C-137 at the Council of Ricks before the collapse of the Galactic Federation. And I asked him to sketch that one. I'm like, I'm not sure. I've taken logic classes where you take sentences and render them as formulas, but I don't know how to render that one in this formalism. And then Summer can mail Beth that she saw Rick text Marty. And I'm like, how do you say that something was from Rick and stuff?
I think these are just hints at all of the perverse combinations in Rick and Morty show, how there were all of these Ricks floating around, all these Mortys floating around. How do you know it was the Rick one?
Sure, that's certainly what this one's talking about. But the second one's pretty basic. Rick can mail Beth that she saw. Summer can mail Beth that she saw Rick text Morty. Yeah,
the question is, which Rick?
Right, but this example doesn't get into that.
Yeah.
But what I don't understand is how can you make a claim that somebody did a sending behavior?
I see.
Let alone who the sender was. I can sort of see how you can see who the recipient is. You look on this end of the bang.
I don't think he meant these so specific but that when you have a lot of bad actors or ambiguous actors, these become hard problems to verify with confidence.
Oh, I'm quite sure he's got an actual formula in mind. I'm quite sure he could render this in rholang like this.
Okay.
I just wanted to do it because I can't do it.
Okay, I didn't know that. Okay.
So, and then he goes on to talk about bisimulation and theory of mind and stuff, and he explained that part to me. It's like, that's pretty interesting.
Yeah. Awesome. Well, guys, it's been a good morning. Have fun and Happy New Year's. If I don't talk to you before then.
Yep. I know.
See ya.
Well, thank you. I'm still am not too much much more clear on how practical this is.
Right.
Um,
Well, I mean, does the email callback thing make sense?
yeah, absolutely.
So in some ways, it's widely practiced already.
Right. Yeah, I guess you know I guess he. I mean, it seems like he's just saying, well, you can look at capability-based behavior as channel-based.
Yeah, and then you can also say you can define an identity as anybody who can behave a certain way.
Right. And I guess my missing thing here is, you've got this big pattern recognition issue that's not really, we don't really have a practical means of determining that. It seems to me.
Well, you just watch the behavior of things on channels, just like just like email callback. That's a real basic behavior, right?
Okay.
Yeah, I think that's going to work. All right. I'm going to sign off for today.
All right, Guy. Thank you much. Appreciate it. Have a good one.
You too.
Happy New Year.